Now, in my previous videos, I had proved that it is our binder content, and this binder content has taken from graph. It was theoretical value coming from the graph at the rate of 4% air voids. But now what will we do? This selected amount of the binder being used along with design aggregate structure number 1. It means I will use the combination of this Pb, which is 4.7%, and then aggregate from this design aggregate structure number 1. If I go through this one, in order to make it 100, 4.7% plus 95.3%. Okay, so it means this is the amount of the aggregate which is being used from this one, and this is the amount of the binder content. Now we will use these two quantities for the development of hot mixed asphalt. Now we want to prove it that this amount of the binder content, if hot mixed asphalt is developed, it is going to satisfy all the characteristics set in the Superpave specification when it is compacted at N dash, mean 100 gyration. Now let me tell you what will we do over here. We will develop hot mixed asphalt by taking this amount of the binder and this amount of the aggregate. And we will perform all the values. Which are those values? Now just for your understanding, we will find out GMM. Clear it? Second, we will find out the value of GMB at the rate of N dash. We will find out the value of GMB at the rate of N initial. Then fourth one, we will find out percentage GMM at the rate of N initial. Number fifth, percentage GMM at the rate of N dash. You know, when this value is being converted to this value, it means I have to also mention over here correction factor C. And next, we will also have to determine the value of dust binder proportion. So from this hot mixed asphalt which has been developed, we have to find out the GMM, we have to find out the GMB at N dash, we have to find out GMB at N initial, percentage GMM at N initial, percentage GMM at N dash, then C, correction factor, because this correction factor is supposed to be for the making the relation, then dust to binder proportion. Clear? Similarly, by knowing these other volumetric properties, so these are our requirements. Now here I would like to tell you one thing. Because you know the procedure how to find out the GMM. You know the procedure how to find out the value of GMB. You know all these procedures I have explained all in my previous video. Over here I will just go on writing the values. Understand my point? I will not go in detail what is the GMM, how will we find out, blah blah. No, I will just write down the value which has been taken by the mix of this material with this proportion. And I will only write those value. Then with the change of this value, I will go on telling you that this value is acceptable and this is as per our Superpave specification. You just see it, please. Like first value which I have already told you, and this value is our correction factor. Correction factor. When this value calculated, it is equal to 0.92. This is the C value. Clear it? Similarly, next I will tell you about this value of this GMM at Pb is equal to 4.5%. Sorry, 4.7%. The value of GMM comes out to be 2.670. When this GMM is determined by this method, then we have to calculate the value of GSE. And this value of GSE coming out to be 2.897. Now I am not going to give you the calculation. Directly I am going to write down the value over here, which I have already taken their calculation. Next, after writing these two values, now I will write down the value of GMB at the rate of n dash. It is equal to 2.557. GMB at the rate of n initial. It means here C is carrying this value. When I will, this and this value is being multiplied. After their multiplication, the value which is being obtained over here, it is equal to 2.352. Clear it? Now, after writing these values, now we have to go to our other volumetric properties. From these volumetric properties, the first value being taken over here is the air voids, VA. And you know its relation, GMM minus GMB over GMM into 100. After putting this value, the amount of air voids comes out to be 4.2%. So it is specification requirement is 4%. So it means it is acceptable. Next, VMA. You know this formula, 100 minus GMB PS over GSB. This GSB for our design aggregate structure number 1, 2.896. How many times we have taken? This GMB just calculated over here, and PS already I have told you, 95.3. And from over here, this value calculated for this air voids, VMA, it is equal to 15. Now this value is greater than 14. It means this condition is also satisfied. Next, VFA. VMA minus air void over VMA and 100. Now both the values are over here. When these values are put in this equation, we are going to get its value 72. And this value is well between 65 up to 75. It means my this condition is also satisfied. After writing this value, we have to calculate dust binder proportion dP 75 over Pbe, effective spark binder. Over here the value comes out to be 0.8 and it is well between 0.6 up to 1.2. So all this calculation shows that our final accepted design asphalt content is equal to 4.7%. And it is also checked by the mixing of the aggregate and the binder at this value. So that is why whenever we will make the plant trial or whenever we will make the material to be used at the site, we will use this amount of the binder because it is our final accepted amount of the binder. So it was just introduction that whenever you are going to select your material as a DAC and with that same amount of the DAC, you have to verify it. And this verification is done over here. Thank you for seeing this.